This video covers conducting a two-way between ANOVA. When do we use a two-way between ANOVA? When we have two independent variables. Each independent variable has two or more conditions. Both independent variables are categorical. Both independent variables use a between design, and there is one continuous dependent variable. There is a little notation that I want to teach you all. Essentially, you put the number of conditions in independent variable 1 times the number of conditions in independent variable 2 to indicate which between ANOVA you are using. So a 2 by 2 between ANOVA means that independent variable 1 has 2 levels and independent variable 2 has 2 levels. Now, some people get this confused and don't understand that the numbers are the numbers of levels or conditions in each independent variable. So a 3 by 2 between ANOVA has 3 levels or conditions in independent variable 1, and independent variable 2 has 2 levels or conditions. So I know that independent variable 1 has 3 levels because it comes first in the 3 by 2 notation. In this class, I'm only going to cover 2 by 2 ANOVAs. If you find something more complicated, please come do it with me. Now, the goal of this test is you actually test 3 things for the price of 1. And they have interesting names. So the main effect of independent variable 1 is just asking the basic question, are the 2 or more means in the independent variable 1 different from each other? The main effect of independent variable 2 are asking, are the 2 or more means in independent variable 2 different from each other? Now, there's also an interaction term, which is moderation. Is there evidence of moderation? Is the effect of IV1 on the dependent variable different at the multiple conditions of independent variable 2? Essentially, is the effect of IV1 on the dV moderated by independent variable 2? When entering our data in Jamovi, it looks a lot like a between ANOVA or between or independent samples t-test. You have one column for participants. You have one column that indicates what condition of independent variable 1 participants were in. That's nominal or categorical. You have independent variable 2, a column for that. That's also nominal or categorical, telling us what condition of independent variable 2 participants were in. And you have a column of your dependent variable. Now, this shows you how to actually click the buttons to get the analysis. I'm going to let this play for a few times and show you what buttons you need to click. Let's watch that again. So let's look at only the main effect of independent variable 1. On your Jamovi output, you will look for this estimated marginal mean chart that has independent variable 1 on it. Of course, in your data, you will change these names to match the design of your study. But what we're going to look at is pattern. So we see that condition B is greater than condition A, right? So that's our pattern. And then we look at this ANOVA table that Jamovi gives us, and we pay particular attention to the line, to the row, with independent variable 1. So is this pattern where condition B is greater than condition A, is that a significant pattern? Yes, the p-value is less than 0.05. Remember, I'm making up my data, so you won't always find significant results. Now, our next question is, PPP, population effect size. Again, we do not get the 95% confidence interval of partial eta squared, which is unfortunate, which limits our interpretation of our data. But we do get the sample partial eta squared, which is an effect size. And 0.01 is small, 1% is small, 0.06, 6% is medium, and 0.14, 14% is large. This is 76%. So in this case, we know that our independent variable is associated with 76% of the variability in the dependent variable, or 76% of the dependent variable. So we get pattern, P, and effect size. Now we look at the main effective independent variable 2. You will know you have the right graph because it has the independent variable 2 labeled multiple times. Now yours will, of course, label your independent variable 2 from the design. You should change your names in the data file. But we can see here that condition D is higher than condition C. You can see the means at the bottom as well, but that's our pattern. Condition D is larger than condition C. Now, our next question is this a significant effect? We look at the line with independent variable 2. Our p-value is less than 0.05 again, so we know it's significant. So we know this mean difference is better than nothing in the population. And we know the eta squared is 0.93, reminding us of partial eta squared. The IV accounts for 93% of the changes in the DV, or 93% of the DV. This is a large effect based on the 1% small, 6% medium, 14% large. Now, the new concept is the interaction. And I'm going to remind us of the definition of moderation for us to examine if there's an interaction pattern. Is the effect of IV1 on the dependent variable different at multiple conditions of independent variable 2? So if we're looking at this graph, it looks intimidating at first, but you can see that the effect of IV1 is the difference between condition A and condition B, right? So if we look at IV2, we see there are two conditions, condition C and condition D. So the effect of IV1 on the DV, is it different at multiple conditions of the IV? We literally just have to look at these lines. So in the blue line, right, we can see that the effect of independent variable 1 is such that condition B is higher than condition A. At the other level or condition of IV2, condition D, we can see that condition B is higher than condition A as well. So is the effect of IV1 on the DV different at the multiple conditions of IV2? No. You may look at this and be like, oh, those yellow bars are higher, but that does not represent an interaction. The interaction is technically, mathematically, a test of these two line slopes, and these two line slopes are the same. So for an interaction, it doesn't matter if condition D is higher than condition C. We saw that in the previous slide. It just matters that the effect of independent variable 1 on the dependent variable is different at the different conditions. In this case, we can clearly see for both condition C and D of IV2 that condition B is higher than condition A. Now, when you're using real data and you have actual conditions inputted into your file, this will make more sense. But ultimately, an interaction is a test of slope differences. So in this case, we do not see an interaction pattern. And to Just because we don't see an interaction pattern doesn't mean there's not one there. So we look at the interaction line. So our pattern doesn't look like there's an interaction. Okay. But we still have to look at our p-value. Our p-value is 1. This is greater than 0.05. Okay, so we do not have evidence that our effect is better than nothing. Technically, it's inconclusive. And we can see that the partial eta squared is 0, which in terms of partial eta is less than small. There are no post-hocs needed in a 2x2 ANOVA. For independent variable 1, you're comparing two means. There's only one way two means can be different, right? There's not three means to be different, many different ways. There's only one way two means can be different. These two means were significantly different, and so we don't need a post-hoc test. The same goes for independent variable 2. You're only comparing two means. There's only one way two means can be different. And for the interaction, you are technically comparing only two slopes. There's only one way two slopes can be different. If you run a 2x3 or a 3x3 ANOVA, you will need post-hoc tests for the 3-level independent variable and the interaction. I'm not covering these tests, but if you go back to either ANOVA, you will see that all you have to do is click the post-hoc buttons. So that's why I'm not teaching it. You can do this yourself. If you find yourself in a situation where you're running a 2x3 ANOVA for class, come see me. You won't do one on the test.